So this is part 2 of 2D equilibrium of a particle. There are 10 problems here, level 6 to 15. The 1,800 kilogram boat is suspended from two parallel cables of equal length. The location of the center of gravity of the boat is not known. Calculate the force P required to hold the boat in the position shown. So here is the given figure. Let's denote the tension at A as T because they have the same T sub A rather. Let us say this is the weight 1,800 times 9.81, then call that tension A, tension at B. The angle it makes with the vertical is 20 degrees. So first summation for Ry, because this is in equilibrium, R vertical equals 0, and it is equal to TA plus T sub B cosine of 20 degrees minus 1,800 times 9.81. Then we can compute T sub A plus T sub B, 1,800 times 9.81 over cosine 20. So that is equal to 18791 newtons. Then summation, then horizontal component of resultant force should be 0. And that is equal to P minus quantity T sub A plus T sub B sine of 20 degrees. Substitute the value of T sub A plus T sub B, which is 18791, then sine of 20 degrees, then we can solve for P. 18791 sine 20, so that's the value of P. Determine the angle theta for which the 1250 Newton homogeneous cylinder will be in equilibrium in the position shown. Also find the tension in the rope AB. So here is the given figure. So R horizontal is 0, so let's draw the free body diagram first. Let's have the weight 1250 newtons, then tension in AB, T sub AB. So RH again is 0, and that is equal to 500 sine of theta minus 375. Therefore, sine theta is 375 over 500. Arc sine of theta is arc sine of 375 over 500. So we can now solve theta. It is equal to 48.59 degrees. Then R vertical equals 0. So that is tension AB minus 1 to 50 minus 500 cosine of theta, which is 48.59 degrees. So tension AB is 1 to 50 plus 500 cosine 48.59, and that is equal to 1581 newtons. Two cables are tied together at C and are loaded as shown. Knowing that P is 500 newtons and alpha is 60 degrees, determine the tension in cable AC in cable BC. So you can solve this in many ways. As I presented in part 1, I presented 4 solutions, but in this problem, I'll just present one solution. And that is the force triangle method. So we'll call the tension in AC as TAC, which makes 45 degrees with the horizontal and the vertical also. And this one, tension BC, 25 degrees with the horizontal. So let's draw the first triangle. First, we have P, which is 500, and alpha is 60 degrees. So remember 60 degrees with horizontal. Then let's connect tension in AC, which makes an angle of 45 degrees with the vertical, 45 degrees with horizontal. And therefore, because this is vertical, this is 30 degrees because that's 60 degrees, 90 minus 60. The angle here would be 45 plus 30, 75 degrees. And finally, we have tension BC. So that's 75, 45, and 30, 75. So this is 25 degrees from the horizontal tension BC. And the total angle is 60. 60 minus 25 is 35. So this is 35 degrees. That one. And 70 is also 25 from the horizontal plus 45. 25 degrees from the horizontal plus 45 degrees tension AC. So that's 70 degrees. Another way to get 70 is 180 minus 35 minus 75. So we solve tension in AC and tension in BC by sine law. So tension AC as to sine 35 degrees equals tension BC as to sine 75 degrees equals 500 as to sine 70 degrees. As I said, you can solve this by summing up forces horizontal 0, vertical 0, then there will be two equations, two unknowns. So tension AC is 500 sine 35 over sine 70. So tension AC is equal to 305.2 newtons. Tension BC is 500 sine 75 over sine 70. So tension BC is 514.0 newtons. Knowing that alpha is 20 degrees, determine the tension in cable AC in rope BC. So this time, let's have rotation of axis. Let's do first the forces at C. So we have 1,200 pounds and tension BC, which makes an angle of alpha, which is 20 degrees with horizontal. Then we have tension in AC, which makes an angle of 5 degrees with the vertical. So let's rotate the axis so that we'll have one unknown at a time. We can solve it one unknown at a time. We draw a line axis perpendicular to tension BC and call that axis U. So this is 70 degrees, 90 minus 20. So this is also 20 degrees. So call that the V axis. Then 20 degrees, this is also 20 degrees. So that if we sum up, if we equate R sub U, because the system is in equilibrium, RU equals 0, then tension AC cosine of 5 degrees plus 20 degrees or 25 degrees minus 1,200 cosine of 20 equals 0. Tension BC will not be involved. So R sub U equals 0 equals tension AC cosine of 5 degrees plus 20, that component there, then minus 1,200 cosine of 20 degrees. So therefore tension AC is 1,200 cosine 20 divided by cosine 25. So tension AC can now be computed. It is equal to 1,244 pounds. Then RV equals 0, and it is equal to tension AC sine of 25 in the positive V direction. Tension AC, which is 1,244, sine of 5 degrees plus 20, that component there. Then minus 1,200 sine of 20, this component here, minus tension BC. Then we can now compute tension BC, 1,244 sine 25 minus 1,200 sine 20. So as I said, you can solve this in your own way. Any of the four methods that I presented in part 1. Level 10, knowing that alpha is 55 degrees and the boom AC exerts on pin C a force directed along line AC, determine the magnitude of that force, the tension in cable BC. So the force AC should be shown here. So that's FAC. This is 30 degrees. And we have tension BC. So we draw the force triangle this time. So first we have 300 pounds, which makes 30 degrees with the 20 degrees with the vertical rather. Then let's connect to the tip of the 300 pounds FAC, which makes an angle of 30 degrees with the vertical. The 300 pounds, 20 degrees with the vertical, so 20 plus 30, this angle is 50 degrees. Then we connect from the tip of FAC tension BC, which makes an angle with the vertical of alpha, and alpha is 55 degrees. So this is 50 degrees because the 300-pound force makes an angle with a vertical of 20, and FAC makes an angle with a vertical of 30. So 20 plus 30 is 50 degrees. Then we draw vertical line here. This angle is alpha, 55 degrees, and this is 30 degrees FAC, makes an angle of 30 degrees with the vertical. Therefore, this angle is 180 minus 55 minus 30 degrees. So this is 95 degrees. The remaining angle here is 180 minus 95, 85 minus 50, so 35 degrees. Then we solve for FAC and tension BC by sine law from this triangle. So FAC as to sine 35 degrees equals tension BC as to sine 50 degrees equals 300 as to sine 95 degrees. So FAC is 300 sine 35 over sine 95. So FAC is 172.7 pounds. Tension BC is 300 sine 50 over sine 95, and that is equal to 230.7 pounds. A welded connection is in equilibrium under the action of the four forces shown. Knowing that Fa is 8 kilonewtons and Fb is 16 kilonewtons, determine the magnitudes of the other two forces. So let's put the values. Fa 8 kilonewtons, Fb 16 kilonewtons, and this slope is 3, 4, 5, so 5 hypotenuse. So R horizontal is 0, and that is equal to negative 8 times 4 over 5 for this force here. Its component is negative to the left, 8 times 4 over 5. This component, horizontal component here is positive 16 times 4 over 5, then minus FAC. FD is not involved because it is vertical. So from here we can solve FC, negative 8 times 4 over 5 plus 16 times 4 over 5. So F sub C is equal to 6.4 kilonewtons. R vertical equals 0, and it is equal to negative 8 times 3 over 5 for this component here. It's going down. This one is positive 16 times 3 over 5. FC is not involved, then minus FD. Then FD is negative 8 times 3 over 5 plus 16 times 3 over 5. So FD is 4.8 kilonewtons. So that's it. Level 12 problem. Two cables tied together at C are loaded as shown. Knowing that Q is 60 pounds, determine the tension in cable AC, then in cable BC. So by looking at the figure 60 degrees, so that means this angle is 30 degrees. So therefore, this tension in BC and this 75-pound force are collinear. And because this is 30, 60, so that means it's perpendicular here. This is 90 degrees. So we rotate the axis so that we can solve for the tension in AC directly. Then after that, tension in BC. So let's call this tension AC, tension BC, and let's call that axis U. So this is 60 degrees also. Q is 60 pounds as given in the problem. Call that U axis, then in that direction the V axis. So that RU is 0, then it is equal to tension AC, then minus the component of 60-pound force, which is opposite to 60, so minus 60 sine 60. These two forces are not involved because they are perpendicular to axis U. So tension AC is 60 sine 60 degrees, and it is equal to 51.96 pounds. Then RV is 0. It is equal to 75 positive, then minus component of 60 pounds, which is this component here, which is 60 cosine of 60, then minus tension BC. Then tension BC is 75 minus 60 cosine 60, and that is equal to 45 pounds. Level 13 problem. A sailor is being rescued using a boatswain's chair that is suspended from a pulley that can roll freely on the support cable ACB and is pulled at a constant speed by cable CD. Knowing that alpha is 25 degrees and that beta is 15 degrees and that the tension in cable CD is 80 newtons, determine letter A, the combined weight of the boatswain's chair and the sailor, and letter B, the tension in the support cable ACB. So here is the given figure. We will call the tension in ACB as T. So tension T, that's also T, same tension to to the side of the pulley, frictionless pulley. Then tension in CD is 80 newtons. Alpha is 25 degrees, beta is 15 degrees. And the weight of the combined weight of the both Wayne's chair and the sailor, call that W. So first, R horizontal is 0 and it is equal to T cosine 15 degrees for this force, for this tension. Then minus T cosine 25 for this tension here. Then minus 80 cosine of 25 because these two are parallel. So from there, we can solve tension, which is tension in ACD, equals 80 cosine 25 transpose, then divided by quantity cosine 15 minus cosine 25. And that is equal to 1216 newtons. Then R vertical equals 0. It is equal to T sine 15 degrees plus T sine 25 degrees plus 80 sine 25 degrees. Those are the components, positive. Then minus W. So substitute the value of T, which is 1216. So 1216 quantity sine 15 degrees plus sine 25, then plus 80 sine 25 degrees minus W. So W transposed to the left, so it is 1216 quantity sine 15 plus sine 25 plus 80 sine 25. So using your calculator, W is equal to 862.4 newtons. Level 14, two cables tied together at sea are loaded as shown. Knowing that the maximum allowable tension in each cable is 800 newtons, determine the magnitude of the largest force speed that can be applied at sea, the corresponding value of alpha. So we have P here, unknown, then alpha, unknown also. So the tension in each cable is limited to 800 newtons. So let's show it 800 newtons. 800 newtons. The angle here is 50 degrees with horizontal. Then here it's 35 degrees. So first, R horizontal equals 0. And it is equal to P cosine alpha for this force here, positive. Plus 800 cosine 50, positive. Then minus 800 cosine 35. So simplifying, P cosine alpha is 800 cosine 35 minus 800 cosine 50. Call that equation 1, so 141.09. R vertical equals 0, and it is negative P sine of alpha for this force here going down. Then plus 800 sine 50 degrees. Then plus 800 sine 35 degrees. So transpose this to the left. So P sine alpha is 800 sine 50 plus 800 sine 35 degrees. And that is equal to 1071.7 equation 2. So divide equation 2 by equation 1 to solve for alpha. P sine alpha over P cosine alpha equals 1071.7 over 141.09. So cancel P. This is tangent alpha equals 1071.7 over 141.09. Therefore, alpha is inverse tangent of 1071.7 over 141.09. Using your calculator, alpha is equal to 82.50 degrees. Then substitute into equation 2 the value of alpha to solve for P. So P sine of 82 0.5 degrees is equal to 1071.7. So the maximum value of the largest force P that can be applied at sea is equal to 1081 newtons. Level 15 problem, a 160 kilogram load is supported by the rope and pulley arrangement shown. Knowing that beta is 20 degrees, determine the magnitude and direction of the force P that must be exerted on the free end of the rope to maintain equilibrium. So here is the given figure. Because pulleys are frictionless for this problem, then whatever is the tension on this side, that's the tension here. That's also the tension here. So let's show the forces P, P. So take note that this P here may be inclined downward through an angle of alpha also. The equation is still the same. So there are two expected answers for P and for alpha. So first, R horizontal equals 0. So by the way, this is beta, which is 20 degrees with the vertical. So these two. So R horizontal is 0, and that is these two P's here with the same inclination have positive horizontal components. So 2P sine of 20, that component there, opposite of 20 degrees. So 2P sine of 20 degrees. Then if this is the first possibility of the other end of the rope or cable, then the component is negative P cosine of alpha. So even if it is inclined downward through the same angle, it is still minus P cosine alpha. So divide everything by P, we can cancel P, then cosine alpha is 2 sine 20 degrees. So therefore alpha is inverse cosine of quantity 2 sine 20 degrees. So we can now find alpha. It is equal to 46.84 degrees if this is the possibility. The other value of alpha is same 46.84 in this direction, because if it is inclined downward through an angle of alpha in this direction, the equation RH is the same, and we get the same alpha, magnitude of alpha, but in the other direction. It is below the horizontal. So using this alpha and this possibility here, let's solve for P. So from the figure, R vertical equals 0. So this is the other possibility, but alpha is still the same, but it is below the horizontal. So R vertical equals 0 equals 2P cosine of 20 degrees plus P sine of alpha. P sine of alpha. Then minus 160. This is not yet included. Just consider this force P here. Minus 160 times 9.81 to convert it to newtons. So therefore, 160 times 9.81 equals 2P cosine 20 plus P sine of 46.84 degrees. So the value of P is 160 times 9.81 divided by the quantity 2 cosine 20 plus sine 46.84. So P is, for the first possibility, is 601.6 newtons if it is inclined in that direction. If it is inclined in this direction, the angle alpha is still the same because we will have the same equation for RH. So alpha is 46.84, but it is inclined downwards in this manner, 46.84. Then for RV vertical, because this is now the second possibility, RV vertical equals 0 equals 2P cosine of 20 degrees, then minus P sine of alpha, then minus 1,600 times 9.81. So 160 times 9.81 equals 2P cosine 20 degrees minus P sine of 46.84 degrees. The value of P this time is 160 times 9.81 divided by quantity 2 cosine 20 minus sine 46.84. So using your calculator, P is 1365 newtons, but it is inclined in that direction. So that's it for these problems here. We'll have part 3, levels 16 to 20.